What up, athletes? Whoop, whoop. All right, so I'm excited today. We're going to get some real-life graphing. But don't freak out. We're talking about graphing using like a graphing calculator or Desmos, which I'll be demonstrating here in a minute. But right now, I want you to take a minute, and I want you to draw this table where we see equation on the left, 3x equals 6, or x squared plus 4x minus 5 equals 0. And on the right, it says it's a related function. So the function that's related to 3x equals 6 is f of x equals 3x minus 6. Or, remember, f of x and y are the same thing. Y equals 3x minus 6. Go ahead and write those down in the same way. The related function to x squared plus 4x minus 5 equals 0 is f of x equals x squared plus 4x minus 5. Or y equals x squared plus 4x minus 5. Pause it if you need to, and then I'm going to move on. Boom, let's move on. All right, so some things to establish here. We talked about this a little bit yesterday, but a root and a zero of an equation are the same thing. A root and a zero are actually for functions. Those are the same thing as a solution to an equation. A solution to an equation is going to be the same as the root or the zero of the related function. And we're going to get more into that. I know that sounds like a deep statement. This is a pretty big slide right here. But what we see right here is, let's look at our x-intercept, and that's what we're really focused on. Our x-intercept is a couple things. So this is the graph of the function f of x equals 3x minus 6, or y equals 3x minus 6. We see 2 right here on the x-axis. That is the x-intercept. 2 is a number of things here. So first of all, I would like you to write down f of x. That's not going to let me highlight it. F of x equals 3x minus 6. Go ahead and just draw yourself this little graph right here. You don't need to get fancy. Just make sure as you draw a straight line, a couple of things you should pay attention to. One, it's going to hit the x-intercept of 2, 0. And the second is it's going to hit the y-intercept of negative 1, 2, 3, 4, 5, 6. Negative 6, 0. Okay? So keep that in mind. And go ahead and graph that. And then I want you to write these key components. We're going to focus on the fact that the x-intercept or the root or the zero of this equation or function is 2, 0. Right? This is the x-intercept. I want you to focus on that because this 2 is a lot of things. And I want you to write each of these down. This 2 is the solution of 3x equals 6. 2 is also the root of 3x equals 6. 2 is also the zero of the function f of x equals 3x minus 6. And 2 is also the x-intercept of f of x equals 3x minus 6. 2 is a lot of things. It's a solution, a root, a zero, and an x-intercept. I want you to focus on that. So just write that down. What comes next is going to be a lot of just, not as much notes as it is going to be looking through graphs and then solving things algebraically to prove it. Pause it if you need to. I'm going to go ahead and move on again. I want you to draw this graph. Label it like I did right here with the x-intercept to 0. Make sure you label the line. Make sure you know that it hits that y-intercept as well. Okay? And do make sure, I guess I can do this, that you write down this function as well. All right, let's move on. I'm going to zoom out a little bit here, I think. I need to. All right, so we're going to talk about how to solve a linear equation by graphing. Okay, so it says solve negative 2x plus 7 equals 1 by graphing. Check your solution. The first thing we have to do is we're going to write this down, and we are going to solve this for 0 on the right side of the equation, okay? So I'm going to solve this for 0. I get negative 2x plus 6 equals 0. How do I do that? Because I'm going to take negative 2x plus 7 equals 1, subtract 1 from both sides, and again we get negative 2x plus 6 equals 0. Once we get that, what do? I'm glad you asked. How will we get this graph you see right here? Me personally, I'd go to Desmos, I'd plug it in, and when you plug it in, it's going to graph this nice little graph right here. Does everybody see that? And you should notice that this is identical to the graph we see down here. And I need to turn the sounds on my phone off clearly. When I'm looking at here on the graph, I want to find out what is the value of x as it crosses the x-axis, the solution, the x-intercept, right? And so we see it right there. It is clearly at 3, 0. Or, if we're just writing it down as a solution, x equals 3. That's the x-intercept. That's the solution. That's the root. That's the 0 of the equation, okay? So graphically, we've just shown where it's at. And you'll notice, go ahead and write this down, but I'm going to exit it out right here because I want to show you this again. We see that confirmed right here in our graph on Desmos, or if you have a graphing calculator, you can see it. So I just want to make sure you see that. All right. How do we do it algebraically? Well, we're going to check it. To check it algebraically, we're just going to solve it. So how would I solve this? Well, I'd solve it like I'd normally solve an equation. Instead of, notice, to graph it, I had to solve it, or I had to just get everything on one side, 0 on the right. And then once you get 0 on that right side, we replace it with f of x equals negative 2x plus 6. Or on Desmos, I just wrote y equals negative 2x plus 6. That's the related function to this equation. But to solve it and check it graphically, we just solve the equation for x. We subtract 7 from both sides. We get negative 2x equals negative 6. Divide both sides by negative 2, and we get that x equals 3, which confirms our solution of x equals 3, which is the root, right? Which is that x-intercept. Okay. We're going to do this again with a little less direction from the computer, but make sure you see this. Take a moment, write this example down so you know how to solve this graphically. This is just solving an equation like we've been doing it. And we're going to go through this on our own in the next slide. Okay. So again, we're going to do this graphically. Now, they're already going to have the graph, but I'm going to show you how we would do it on Desmos. Okay, so part A, we need to find the related function that is formed by rewriting the equation with 0 on the right side. So to get 0 on the right side, I need to subtract 7, right? So if I subtract 7 from both sides, what do I end up with? I end up with 9 minus 7 is 2, minus 1/3 x equals 0. Now, I'm going to rearrange this part right here. I'm going to rearrange the 2 minus 1/3 x. I would rather it be negative 1/3 x plus, and we see that's a positive 2, so I'm going to put plus 2. See, I'm always going to write it with my x first, or my highest order of x, and we'll get into that when we talk about nonlinear. But so this is now f of x equals negative 1/3 x plus 2. All I did was get 0 on the right side. Once I got 0, and this is a 0, don't make fun of my zeros. Once I got 0 on the right side, I now can say, all right, this is my function. And I just rearranged it to put negative 1/3 x first. So f of x equals negative 1/3 x plus 2. When I put that in my, pause if you need to write this down, but I got to exit out so I can go touch my graphing calculator. Let's take that off. Notice I put y equals negative 1/3 x plus 2. What does that look like? It's like this graph right here. And I can even tell you my 0 should be at 6, 0. So if I solve this for the solution for x, or the root, or the x-intercept, it's going to be at x equals 6, or the point 6, 0. So we can see we have y equals negative 1/3 x plus 2. I have a graph right here. And what do we have the x-coordinate at, or the x-intercept at? It's at 6, 0, which means my solution should be 6. And we're going to talk about how to find that next. Let's go ahead and go back to our McGraw-Hill. You'll see I put the solution, or the f of x, in there. So it's f of x equals negative 1/3 x plus 2. That is our function. Now it says examine the graph of the related function to find the solutions. Well, we already did that. We see that x equals 6. Boom, we got that. Awesome. And if I wanted to solve this, so what was my original equation right here? I could have solved that. So I want you to show you how we could check our solution if we wanted to check it. We have 9 minus 1/3 x equals 7. Well, now I'm going to actually just solve for x. So minus 9 minus 9. I get negative 1/3 x equals negative 2. And then how do I get rid of negative 1/3? Multiply by negative 3 over 1. Those cancel out. Negative negative makes a positive, but I got to multiply this side. Negative 3. It's negative 3 times negative 2. I get that x equals positive 6. Look, that's confirmation of our graph. Boom. All right. Go ahead and pause this if you need to. We're going to move on to our next. Now we're going to talk about what happens if we have a nonlinear equation. Well, if we have a nonlinear equation like we do in the situation up above, first we've got to math out a couple things. Let me zoom in just a tad. Okay, so I have 1/2 x squared minus 2 equals negative 3/2 x. Well, I'm just going to add this 3/2 x over, right? We just want to get 0 on the right side. 3/2 x, add 3/2 x. You may think this is a weird placement on the left side for where I put it, but I have a reason for it. So those are going to cross out. What am I going to be left with? I'm going to be left with 1/2 x squared. Notice that's x squared. I cannot combine that with this x. But then I'm going to put plus 3/2 x. So I got 1/2 x squared plus 3/2 x. And then we have the minus 2, and that all equals 0. So if that's true, go ahead and write that down real quick what we just did, because I'm about to delete it. Then I'm going to write down in here. All right. So this is the editor. If you ever want to know how you do this. 1/2 x squared plus, remember I added that over and got 3/2 x. So I'm going to click that again. Let's get my fraction, 3 over 2. And then plus what? Well, we're adding a negative 2. So that's plus negative 2. And it really should just be minus 2, but there we go. That's plus negative 2. Okay. Now, here's what I've done. It says to solve for the zeros by graphing. Okay? So just like I did in the last one, look at this. Notice I have here 1/2 x squared plus 3/2 x minus 2. They had plus negative 2. A plus minus is a minus. Let's turn that graph on, and let's select it. Look what we get. We see we have one solution at negative 4, 0. So x equals negative 4 is the solution. We have another solution at 1, 0. When we're talking about a nonlinear graph, there are going to be multiple solutions many times. In this case, there's 2. There could be many, many more, though. So again, this is a parabola, and it's going to make negative 4 as a solution, and positive 1 is a solution. So let's look back. And let's see, we have the graph right here again. I just want to show you how I graphed it myself and how you guys could graph it yourself if you're not provided a graph, although you will be for the homework assignment for the foreseeable future. First of all, does this equation have 2 solutions? True. The function intersects the x-axis in 2 places? Yeah. X-axis once, x-axis twice. Negative 2 is a solution of the equation. Well, let's see. 1, 2. No, that's false. The function has 2 zeros. Yeah. 1, 0, 2 zeros. That's true. The function is linear. That's false. This is not a line. This is a parabola. Negative 4 is a solution. Let's see. 1, 2, 3, negative 4. True. The function has 1, 0. We already said it had 2, so that's false. 1 is a solution of the equation. Let's see. 1, yep. We'd already explored that. True. Boom. Look at that. We're on a roll. What happens, though, if there's a horizontal line? So we've ran into and we've talked about the concept of no solution. Well, I want to talk about what that really means in terms of graphing. So let's look at this right here. 4x plus 3 equals 4x minus 5. Now, most of the time I tell you guys, hey, we're going to end up getting rid of the 4x's and we're just left with 3 equals negative 5. That's no solution. But let's carry this a step further. So we are just going to still solve for 0 on the right side, which means first I'm going to add 5 to both sides. I get 4x plus 8 equals 4x. Subtract 4x from both sides and we get 8 equals 0. Again, we normally just say no solution, but let's talk about what does that mean graphically. Well, That would be the equivalent of saying f of x equals 8, which we see right here. And you'll notice, once again, I did this. Oh, I got to exit out. I did this in Desmos. I did just y equals 8. And let's turn off the last graph, turn this on. And look, there's a horizontal line at y equals 8. But notice, remember, a solution has to pass through the x-axis. This will never pass through the x-axis. So although it does not have a solution, it still has a graph. And it is still a function because it'll pass the vertical line test. What? So this is the graph of y equals 8. It's just a line that goes through y equals 8 and keeps going left and right. And we see that right down here as well, where if I were to control minus, 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 we see that this goes up 1, 2, 3, 4, 5, 6, 7, 8, and it's just a horizontal line left and right. So that is solve an equation of a horizontal line by graphing. It has no solution, but it does have a graph. We're going to look at one more of these. We'll do this one ourselves. Look at this, 2x minus 4 equals 2x plus 6. Again, we see those two x's are just going to subtract out, and then I'm going to add 6 to both sides. Remember, I want to get that 0 on the right, and I'm going to get what? Negative 4 plus 6 equals, we have 2 equals 0. So that means my y equals 0, or I'm sorry, no, what am I doing there? I'm wrong. My y equals 2, or my f of x equals 2. And which one is that? Go ahead and write this down if you need to, but I'm going to exit out of it. F of x equals 2 right here. Boom. Then down here, examine the graph of the related function to find the solutions. What do we see? No solution. Nothing goes through it. See? Because it's not. And again, in my Desmos, what do we see right here? If I turn on my y equals 2, it's a line through y equals 2. Same as what we are provided down here. The reason why I keep going back to Desmos is to show you guys. Desmos.com, just hit start graphing. And I just write in these equations. One of the ways you write in the equation, so I like to use the virtual keyboard right here. And I would say like to do one with x squared, I'm going to say, all right, what do we got? Let's say 3 divided by 5. See how it comes out like that? But to get that thing out from the denominator, I'm going to go over 1. And I'm going to say x, and then I want it squared. And then maybe plus 2x. And then minus 5. Look at that. See how we've got this graph right here now? Okay. We can see the zeros of it right here. Boom. It's even showing me where it intersects other graphs, but that's just because I left them turned on. So that's how you would enter an equation in Desmos. And then notice by clicking on and off, I turn on the graph. You can also delete it, all that good stuff. So Desmos is super powerful. I recommend using it a lot as we go further. Okay. And last but not least, we're going to talk about how to estimate solutions by graphing. So what if I just give you a graph and I say, hey, tell me what you think about this. And I'm going to zoom in a little bit so it's a little more clear about what's going on here. Let's turn this full screen. That is way too much zoom happening. There we go, that's better. Javon is on his way home from a vacation. He's starting at 818 miles from home. So we're at 818 miles right here is what it's telling us. From home and drives about 65 miles per hour. The function d equals 818 minus 65h represents Javon's distance from home. D, after driving 8 hours. Makes sense if he's going 65 miles an hour. Multiply that times how much time he's driving and subtract that from 818 to figure out how close to home we are. How many hours does it take Javon to get home? Well, we see right here, each tick mark is 2 hours. That means this halfway point is 13. So it says estimate to the nearest tenth how many hours it takes Javon to get home by examining the graph of the function. If I'm looking right here, guys, there's a lot of leeway. And I've tested this out. This accepts a lot of answers. I'm saying that looks kind of like 12.5, but maybe you think 12.7. Either one, it's going to accept. 12.5. Look at that. And if I were to reset this and go down, and you're like, but I thought it was 12.7, what happens? Well, we're estimating. It's got a lot of leeway. As long as you're within the 12 market, we're going to be fine. Solve algebraically to verify your estimate round to the nearest hundredth. Okay, now I've got to do some math. So I've got 818 minus 65h. Now, you may be wondering, what do we do with that second variable? Well, I want to know the time. What is the value of our distance when we're at home? Well, our distance will be 0. So the equation we're going to be left with is that 0 equals 818. Or actually, I like to write it the other way. So I'm going to write 818 minus 65h equals 0. There we go. I like that better. And what am I going to do? Well, I'll subtract 818 from both sides. I'm not afraid of negatives. Negative 65h. Oh, what did I do? I've been doing that lately. I'm writing when I'm thinking ahead. Equals negative 818. Undo that with division. We're going to divide by negative 65. And I don't know. I'm definitely going to get a calculator for this. And it says round to the hundredth, so I'll probably have to. So 818 divided by, all right, and I get, so negative divided by negative is a positive. And I get approximately 12.8, or excuse me, 584, which means I'm going to cut this off right here and go 12.58. Okay, write this down. I'm going to erase it and put in 12.58. 12.58 because it said nearest hundredth. Let's check it out. Boom, we got it. What assumption did you make when solving this problem? Select all that apply. Javon drove exactly 65 miles per hour the entire drive home. We did assume that. That's a huge assumption. We kept it straight. It's a linear equation. There's no squiggly lines of him speeding up or slowing down. It's just 65. He didn't stop for nothing. Javon was 818 miles from home when he first started driving. We assume that. Javon drove the entire way home without stopping. We assume that. That's where assumptions were made. Okay, I wanted to know, why did it count this wrong? And I'm going to tell you, this isn't an assumption. It's because we were given this. Because I'm giving, that's not an assumption. That's something I'm told. So it'd be only these two. It wouldn't be B. That was my bad. Look, sometimes I make mistakes too, and I like to leave it in so you see it happen. All right, now that you know, it's time to get ready and get your math on. Peace out.